Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to day 57 session. Today we are just going to discuss about Python closure and how to define the closure and the reason you should use it. And before understanding what is Python closure, let us just discuss about higher order function. And see here, dear friends, we are having some functions which is said to be as a higher order, or a function can take one or more function as a parameter. A function can be returned as a result of another function. A function can be modified. A function can be assigned to a variable. And see here, dear friends, let me just see it with as a parameter, function to as a parameter. So first here is the example. And for your information, see here, this def sum number is a normal function. And it's just going to return the nums. And here it just returning the sum of nums, which is also a built-in functions. That is the sum functions. And next, see here, dear friends, one more function we have been defined, that is higher order function, where it just has two parameters. One is the function and the next is the list. And here the summation is the resultant of to the function f of list. And to be surprising, added to that, the f which is here is the sum number, and here when on just calling this sum number, it is going to return the sum of the numbers. And what is the sum of numbers? Here it is the list. And see here, dear friends, when on just making this summation, what we get as a resultant is the 15. Yes. So when we add all this, the list element, and it is just going to be as a nums, and when you are just returning the sum of nums is the return value of this f of list. And what is the f of list? Is the exact summation that is going to be the result. Okay, let me just see it with another example, that is function as a return value. And see here, dear friends, here we are having a square function, cube function, absolute function, and among that, and one more function is their higher order function. And here what we are just having is returning a value. And what is it returning? Is the type of a data. And here if we are just giving the exact functionality, so if the type is equal to square, or if the type is equal to cube, or if you are just performing for an absolute function, yeah, here it is the exact type of the function. And with that, it is just going to make the call of the particular or exact respective function. And see here, dear friends, for your information, the first function which we are just specifying is a square, and so that it just calls the square of x, and what is x here is 3. And so what it just returns? It returns the square of that x value. And if you want the cube, yeah, it is going to be the cube of that value. And when on just making the absolute, yeah, if it is going to make an absolute value, yeah, that is just checking whether it is a negative or that is greater than 0 or not. If it's so, if it is greater than 0, it is going to give a positive, or else it is just going to give you the negative value. So here you can just see this exact example that gives you the higher order function. Just see here, I have already specified that different function depending on the passed parameter. And what is the parameter here? It is we are having different types of parameters, that is square, cube, and absolute. Okay, let me just move on to the next one, non-local variable in a nested function. See, before getting into what a closure is, we have to first understand what a nested function and non-local variable is. See, a function defined inside another function is called a nested function. And the nested function can access variables of the enclosing scope. And in Python, these non-local variables are read only by default, and we must declare them explicitly as non-local in order to modify them. And here it is, there is an example of the nested function accessing a non-local variable. A nested function that is accessing the non-local variable. And see here, dear friends, we are having a print message. This is the exact function, and inside it has a method, that is a function inside a function, which we just specified, the nested function printer. And we are just going to have the usage of that message. And when on executing this function, we would just get the output as hello. And for your information here, the printer function was able to access the non-local message variable of the enclosing function. So here it is the function where here to the print function, this message is a non-local enclosing thing. So let I just execute. See here, we are getting the output. Okay, now let we jump on to the closer function. See here, dear friends, Python allows a nested function to access the outer scope of the enclosing functions. And here, this is known as the closure. Let us have a look at how closure works in Python. See, in Python, closure is created by nesting a function inside another encapsulating function and then returning the inner function. And in the above example, what would happen if the last line of that print message here, this print message, returned the printer function instead of calling it? This means the function was defined. How it just going to be is here. See here, I just scroll above. See here, here it is just making the printer function. Rather here, if it is returning the function, instead of calling it, what it just happens? That's usual. Yeah, it is also going to give you the hello. Yeah, function was calling the string hello, and the return function was bound to name another. On another calling, on calling this another, the message will still remembered, although we have already finished executing the print message function. And see here, dear friends, this technique was by which some data, that is hello is in the case, get attached to the code is called closure in Python. And this value in the enclosing scope is remembered even when the variable goes out of the scope or function itself is removed from the current namespace. Okay, try running the following in is cell that is Python cell to see the output. Yeah, here too we are just getting it. So here it is the another, and here when on just calling it, we are just getting it. And when on just making this, see here we have already deleted the print message. And what would be the print? Now here is the output. So once after making this print, yeah, here it is the exact original function was deleted. Okay, now the main thing, when do we have closure? Kindly observe. See here, dear friends, as seen from the above example, we have a closure in Python when a nested function references a value in its enclosing scope. So the criteria that must be meet to create closure in Python, or the first one is we must have a nested function, that is function inside a function. The next one, the nested function must refer to a value defined in the enclosing function. And the last is the enclosing function must return the nested function. So in that mean, it is the use of closure. And when to use closure? So what are closure good for? See, actually closures can avoid the use of global values and provide same form of data hiding. So it can also provide an object-oriented solution to the problem. And when there are few methods, that is one method in most cases, some form of data hiding that is to be implemented in the class. Closure can provide an alternate and more elegant solution. See, but when the number of attributes and methods get larger, it's better to implement a class. Okay, here is a simple example where a closure might be more preferable than defining a class and make objects. So, but the preference is all yours. Whether do you want to make as a classer or do you want to make as a closure? So see here, dear friends, here we are having a function make multiply of, and inside that we are defining one more multiplier, the function, that is the nested function. And here on returning, it just gives you the value and that to the multiplier. And see here, dear friends, when on just calling the times 3, and here make multiple of 3, and times 5 is the value, that is make multiplier of 5. And when you just make the multiplies, that is 3 multiplies of 9 and 5 multiplies of 3, and see here to the last, times 5 of times 3 of 2, times 5 of times 3 of 2. Here how this, yeah, here it is an output of 30, but even though I just specify the what would be the inner, that is, see here what we are just having, time 3's of 2 is 3 into 2, which we are just making the times of 5, where we are just going to multiply it with the 5. So this is how which we just get 3 into 2 is 6, which is multiplied by 5. We just get the output 30. Let I just execute it and show you, yeah, 27, 15 and 30 here. Now, how this can be done with one more example. I'm just showing here. See, here it is an information add 10, sorry, function add 10, and inside that we are just declaring a variable 10 is equal to 10. One more function, we are just going to define it inside the add 10 as add, and that variable you can just make use of non-local variable here, and it returns the add. And when on calling this function add 10, here is the closure result. And if you want the closure result of 5 and the closure result of 10, is here the executed one. So where 5, which is added to 10 and returns the value 15, and if you just give the number 10, and if it is added to the exact 10 variable, and it just returns the 20. Okay, before ending to this closure, I just want to give you a lead about the decorators, where tomorrow we are just going to see about this. See, the Python decorators make an extensive use of closure as well. On a concluding note, it is good to point out that the values that get enclosed in the closure function can be found out. And all functions objects have a closure, that is double underscore closure attribute that returns a tuple of cell objects if it is a closure function. And see here, referring to the above example here, that is times 3 and times 5. Let me just make use of it. First, I execute this, make multiply of. So here we are just getting the object, and the cell object has the attribute cell content, which stores the closed value. And see here, dear friends, what is the exact cell content of the times 3? It is about the 3. And what about the times 5? It is on 5. Okay, dear friends, let me just stop here for this today's day, and tomorrow let me just discuss about the decorators in detail. And thank you. Have a nice day. Bye.